Hello students, welcome to your classical mechanics class. Today we will discuss about the conservative forces. You are familiar with the electrostatic forces between the two charged objects or particles and the gravitational force between the two masses. These are the examples of conservative forces. A force is said to be conservative if the work done by the force in moving a particle from one point to another point is independent of the path followed. That means it depends upon the initial and final position of the particle, not depends on the path followed by the particle. So let us discuss what is the conservative force. Suppose we have a frame of reference represented by S with origin O. Now suppose a heavy mass is placed at origin O, let it be capital M. Another mass, small m, is placed at some point P, and as the force between the two masses, small m and capital M, is gravitational force, and it will act along the line joining these two particles. So this is the gravitational force F acting on particles small m due to this heavy mass capital M. Now we have to find out the work done by the force, this gravitational force, as we move the particle from point A to B. Suppose these two points. So we have to calculate the work done by the force F for moving the particle from point A to B. Now we suppose at some time particle is at point P and it moves a small distance dr along this path and reaches some point Q. So first we will find out the work done by the force for moving the particle from point P to Q, and then we will integrate it along the whole path A to B. So this is, let this path be path number 1 followed by the particle. Okay. So by definition, work done, small work done by the force in moving a small displacement dr, that dw is equal to F dot dr. F is this gravitational force. Now, as the particle moves along the path AB, then work done along the path AB is equal to the integral from A to B F dot dr. Now, this force is gravitational force. We know F is equal to, you have already studied in your junior classes, Gmm upon r square. So, by using this value here, we will get A to B Gmm upon r square into dr. So, suppose the position vector of point A is Ra and position vector of point B is Rb. So it's better to write here as Ra to Rb. G is constant, capital M is constant, small m is constant, dr upon r square. So 1 upon r square integration is minus Gmm upon into 1 upon r, limit Ra to Rb. So it will be minus Gmm 1 upon Rb minus 1 upon Ra. Finally we have Gmm 1 upon Ra minus 1 upon B. So this is the work done by the force for moving the particle from point A to B along path 1 which depends upon RA and RB, that means it is independent of the path followed by the particle but depends upon the initial position and final position at its depends on RA and RB in this expression. Let it be expression 1. This is bulk. WAB. Or we can say that a force is said to be conservative if work done by the force in moving a particle from one point to another point is independent of the path followed but depends on the initial and final position. Now consider this particle moves another path. Let it be path number 2. It moves from A to B along this one. Path number 1. This is path number 2. Now, since we know the work done is independent of the path followed but depends on the initial and final position, so the work done WAB along path 1 is equal to WAB from point A to B along path 2, because either the particle follows path number 1 or path number 2, the position coordinates of point A and B are same, so that means work done will be same along path 2. Now, if particle moves from point A to B along path 1 and from B to A along path 2, see, from B to A along path 2, then the work done along path 1 is equal to the negative sign. With negative sign, WAB along path 1 is equal to negative of WBA from B to A, then it will be RB to RA, then definitely there will be negative sign. That means I will write minus WBA along path 2. So from these two terms I can write WAB along path 1 is equal to minus of WBA along path 2. So it will be WAB along path 1. This term on this side it will be positive. WBA along path 2 is equal to, I am repeating what I did. WAB along path 1 is equal to WAB along path 2 because work done is independent of the path followed according to the conservative force nature. Now, in second step I write WAB along path 2 is equal to WBA along path 2, but with the negative sign. So I write along path 2 equal to negative of WBA along path 2. Now we know WAB along path 1 is equal to WBA along path 2, but with negative sign along path 2 B to A with negative sign. So by combining these terms we can get finally WAB along path 1 plus WBA along path 2. That means we are starting from point A and reaches at point B, and then from point B and again reaches at point E. That means we have covered our closed path. That means finally we can write it as closed integral. What is work done? F dot dr. What is work done? F dot dr is equal to 0. So this is the another way to say that a force is said to be conservative if work done by the force in moving a particle along a closed path is 0. Now, by Stokes theorem, you know by Stokes theorem, you can go through the lecture on Stokes theorem in electricity and magnetism. We know by Stokes theorem, closed integral f dot dr is equal to surface integral del cross f dot ds. How can we write this? You can go through the lectures on Stokes theorem. So with the help of this, we know f dot dr is 0. So finally we have del cross f is equal to 0 because close to the integral f dot dr is 0. Finally we have del cross f equal to 0. So what is this del cross f? This is the curl of a force is 0. That means a force is said to be conservative if its curl is 0. There is another way to state that. Now, a conservative force can always be expressed as the negative gradient of scalar function called the corresponding potential. Now, if the force F is conservative, then the force F is representing a negative gradient of scalar minus del u. Now, let us proceed to prove this result F equal to minus del u. Now, we know in your electricity and magnetism class we discussed about that the potential at a point due to a force field is defined as the amount of work done in bringing a particle from infinity to that point. That means potential is amount of work done. What is the definition of work done? F dot dr. Amount of work done in bringing a particle from infinity to that point, from infinity to that point. Let that point be at position R against the force field. Against the force field. So by definition we can write mathematically potential is equal to negative integral minus infinite to R F dot dr. Now, what is this F? F is F x I cap plus F y j cap plus F z k cap. This is the force in terms of components, and vector dr is dx I cap plus dy j cap plus dz k cap. We write f and dr in terms of their x, y and z components. Now we will substitute here u equal to minus infinite to r f x I cap plus f y j cap plus f z k cap dot dx I cap plus dy j cap plus dz k cap. So we will get fx dx plus fy dy plus fz dz. Now, by differentiating on both sides, we will get du equal to minus fx dx plus fy dy plus fz dz. Okay, so what is du? We can write du as curl u upon curl x dx plus curl u upon curl y dy, because it is a component, it depends on both x, on the x, y and z components. So we can write it as du equal to curl u upon curl x dx plus curl u upon curl y dy plus curl u upon curl z dz. So finally, from these two equations, we will get minus fx dx plus f by dy plus fz dz is equal to curl u upon curl x dx plus curl u upon curl y dy plus curl u upon curl z dz. So from this equation we will get fx equal to minus curl u upon curl x, fy is equal to minus curl u upon curl y, and fz equal to minus curl u upon curl z. So as the force F is written as fx I cap, so it will be minus curl u upon curl x I cap plus f by j cap, f is negative sign common, curl u upon curl by j cap plus curl u upon curl z t cap. So we can write it as minus del u, or you can write here minus curl upon curl x I cap plus j cap curl upon curl y plus t cap curl upon curl z. You have common, so from here you can write it as like this minus del u. So this is del operator, curl upon curl x I cap plus t cap curl upon curl y plus t cap curl upon curl z. For del operator and for Stokes theorem, you can go through the lectures in your electricity and magnetism class. And this is all about the conservative forces. Finally, we have three ways to know about the nature of force. If a force is independent of the path following and dependent on initial and final condition, then a force is said to be conservative. Second way is if the curl of a force is 0, then a force is said to be conservative. Third, if the work done by the force over the closed curve, that means F dot dr is 0, then again a force is said to be conservative. And if a force is conservative, then it can be expressed as the negative gradient of some scalar function f equal to minus del u. So this is all about the conservative forces. Thank you for watching.